ratios in right triangles. Who's gonna be my clicker? Somebody go click. Thank you. All right. Okay, so first let's talk about how we name the sides of a triangle. The hypotenuse, which is always where? Across from the right angle. So, if we're like Schieber and we're sitting on the pot, we are looking at the
God.
Okay, the hypotenuse. Schieber. Okay, let's refocus. I swear.
No. You just filmed that his.
No, I did not. Okay.
But if you did, would you be really mad?
Yes.
You think you could possibly get in trouble for that?
Possibly.
Okay.
Okay, let's keep going. Alright, so then where are the legs of this thing?
A and B.
Good. These would be the legs.
But if I were to do something like that, you could probably just cut it out, right?
Schieber, don't. Okay. Alright, now, there's something else that we haven't touched on that much, okay? About it's the side adjacent and the side opposite. All that depends on what angle we are orientating ourselves with, okay? If I'm using angle B, okay, what would be the side opposite of B?
B.
A.
Little b. This one would be opposite. Okay? Now, what's the one that we said never ever changes? What did we say never ever changes?
Angle and hypotenuse.
The hypotenuse. Which one's the hypotenuse, A or C?
C.
Okay, so that leaves A as the side adjacent. Do we remember what adjacent means?
Right next to it.
Good. They share a vertice. They're right next to each other. There's no gap in between them. Okay? But what if I was using A as my angle? What's the side opposite of A?
A.
A.
Little a. Okay, what's the one that never ever changes?
The hypotenuse.
Which would be what in this one?
C.
C.
Okay. Okay. And then what has to be adjacent to A?
Little B.
Good.
Oh shoot, I wasn't taking notes.
You don't need them.
Okay.
Really?
Now, the reason I'm not going to do this last one is we are never going to use C and have opposite, adjacent, and hypotenuse. We cannot ever use the right angle. Okay? Because first of all, opposite would also be the hypotenuse. Okay? So in all of these that we're getting ready to work with today, you cannot orientate yourself with the right angle. It has to be one of the acute angles. What's an acute angle?
Mile.
Smaller
Less than 90.
Less than 90. Good. All right, so go ahead and hit enter.
Don't you dare erase
All right.
that. Don't you dare.
So we're gonna go back to Sokotoa. All right, so Sokotoa is the little Indian guy, and the way we spell that is Sokotoa. Okay, this is the abbreviations for our ratios for sine, cosine, and tangent. Okay, so sine is opposite over hypotenuse. Opposite over hypotenuse. Okay, cosine, adjacent over hypotenuse, and tangent is opposite over adjacent. This is not sin, this is not cos, this is not tan. This is sine, cosine, and tangent. Okay? Go ahead and hit enter. Alright, so what they want us to do is they want us to write the value for sine, cosine, and tangent for what angle?
B.
B. Okay, whatever angle they're talking about, I think it's a great rule of thumb to circle it, so I don't forget where I'm starting at. Okay? And then I like to label my triangle. What's opposite of B?
18.
Good. So I'm gonna label this opposite. Where's the hypotenuse? Because it never ever changes. 33.
Height.
And then what does this one have to be?
A.
Adjacent. Now, there's no value there. So how do I find this value for adjacent?
I don't know.
How do I find missing sides of a right triangle?
Angle.
A square plus B squared equals C squared.
Good. Pythagorean theorem.
No!
All right, remember, if I put my little arrows on the right angles, those always point to what?
Your legs.
Yeah, which are A and B. Okay, so what am I gonna put in for A?
18.
Okay. What am I gonna put in for B?
B.
And C?
33.
Okay, so we're gonna need a calculator here because I have no idea what 18 squared is.
It's actually
324.
4.
33 squared?
1,089.
Okay, how do I start getting B by itself?
Direct.
Okay, so B squared equals? Did you get 765?
Yeah.
Okay, then how do I undo the square?
Take square root of that.
Square root it. Do I need the negative value?
No,
Why?
because a side can't be negative.
Yeah, distance can never be negative. So what is
27 point, not decimal is what you want
what
to
is
go to.
yeah, give me 2 or 3 decimals.
658.
Okay, let's just round to the nearest tenth. So if I round to the nearest tenth, what would this be?
7.
Good. So we're gonna put 27.7 is our adjacent value. All right. So, SOHCAHTOA. So we need to find sine, cosine, and tangent. Every time I work one of these, I write out my SOHCAHTOA. Okay, so sine of, what was my theta gonna be? What angle?
B.
B. So sine of B equals, what's sine?
Opposite over hypotenuse.
Okay, what's opposite? Because we already labeled it.
18.
And what's the hypotenuse?
33.
Does that reduce at all?
No.
By
Yeah,
3.
6
By
over 11.
3.
Oh,
Good, 6 over 11.
hindered.
That was quick. Okay, all right. So let's do cosine. So cosine of, are we doing the same angle?
Sweaty.
We are doing the same angle. Cosine's what over what?
Adjacent over hypotenuse.
Okay, so what's the adjacent value?
27.7.
Thanks.
Hey, Cheever. Over hypotenuse.
33.
Cheever, focus. Okay, so we're gonna leave that one like that. All right, what about tangent? Tangent's what over what?
Opposite over adjacent.
Okay, so what's opposite in this one?
18.
And adjacent?
27.7.
Good. Okay. So we found all the values for sine, cosine, and tangent. Okay. Any questions on any part of that?
No.
Cheever, what about you?
Good.
All right, so go ahead and hit enter. Cheever, are you caught up?
Yes.
Sure?
Yep. So we're just gonna leave them in fractions then?
Yes, we are. His fractions are exact. All right. Each of these sine, cosine, and tangent, they have inverses, okay? The way I remember which one is which is you always have to have an S with a C and a C with an S. And what that means is, okay, cosecant, which we're gonna write like this is how we're gonna write it, is the inverse of sine. C with an S, okay? Cosecant and sine. It's not cosecant and cosine. You can't have a C and a C. Alright, secant is the inverse of cosine. Okay, S with a C. Okay, now tangent and cotangent are inverses of each other. Okay, alright, so a lot of people want to always put these two together like that. Okay, remember S with a C, C with an S. Go ahead and go ahead and go back for just a second. Okay, so look here. What did we say sine was? Sine was what over what?
Opposite over hypotenuse.
So what happened to,
It just flipped.
it just flipped, which makes sense, right? Because if we put this thing over 1, okay, and cause this to be over 1, which would make it cosecant, how do we divide fractions?
Keep, change, flip.
Keep, change, flip, which means that'd be 1 over 1 times hypotenuse over opposite, which gives me hypotenuse over opposite. All it does is flip them. Okay, so cosine is what over what?
Adjacent over hypotenuse.
And all we did was flip it, right? And tangent is,
Opposite over
adjacent.
so all we did was flip it. Okay, go ahead and hit enter. Alright, so let's look at this one. It says, if I give you cosine of theta, find secant. Okay, what do we know about cosine and secant? They are?
Inverses.
They're inverses. So if cosine is 3/4, what's secant have to be?
1/3.
4/3, good. Okay?
That's the answer?
That is the answer.
That was, okay.
Okay? What do we know about cosecant and sine?
They're inverses.
They are inverses. So if this is cosecant, what does sine have to be?
I don't know.
Like this.
Okay. 1 over 1.345.
Good. We could change that into a mixed number and a top-heavy fraction, but we don't need to do that. It's okay. We're not going to do that. All right, so let's find the values of the 6 trig ratios for angle. Which one are they asking me to use?
P.
P. So I'm going to circle this one, okay? And then I'm going to start labeling my triangles. I always do opposite first. What's going to be opposite?
7.
7.
Okay, where's the hypotenuse?
10.
No,
Missing.
miss.
Oh.
It is missing.
Oh.
Okay, so there's my hypotenuse.
Oh,
Okay, so what is 10 then?
Adjacent.
Adjacent.
Adjacent. How do I find what the hypotenuse is going to be?
What is it called?
Good. A squared plus B squared equals C squared. So what do I put in for A?
7.
And B?
10.
So 149 equals C squared.
12.2.
12.2. Let's just round this to a whole number.
12.
12. Let's just make it easy on ourselves. Okay? So we're going to determine the 6 ratios. So I have sine of P, cosine of P, tangent of P.
Yes.
Okay, sine is what over what?
Opposite over hypotenuse.
Okay, so what do I write here?
12. No, sorry. 7 over 12.
7 over 12.
I should be writing this down.
Cosine is what over what?
Adjacent. Hypotenuse.
Good. What is adjacent?
10.
Over.
12.
Can I reduce that?
Yeah.
5 over
Two.
6.
Good. Always reduce if you can. Okay, what's tangent? Tangent's what over what?
Opposite.
Okay, what would my numbers be? Good, 7 over 10. Now that I have the first 3, it makes the reciprocals easy, right?
Yeah.
What's the inverse of sine?
Secant.
S with a C, C with an S.
So
Cosecant. So cosecant P is gonna be what?
12 over 7.
12 over 7. What's the inverse of cosine?
Secant.
Secant. So secant P is gonna be what?
6 over.
6 over 5. Good. And what's the inverse of tangent?
Cotangent.
Cotangent. So cotangent P is gonna be what over what?
10 over 7.
10 over 7. Good. Okay, so far so good?
Almost.
Everybody good on how to use Pythagorean, right? It's a refresher from geometry. Okay, so far so good? You good, Cheever?
Almost.
Okay? Yes.
On the test, will we be able to just be able to round the numbers to whole numbers?
Probably. It's, yeah, probably. Depends on how close they are. Go ahead and hit enter. Is that the last one? Hit enter. Okay. Let's go ahead and do this one. Okay, so there is a thing called special right triangles. So we had the special right triangles that we called do we remember this one? If this side is 3 and this one's 4, what's the hypotenuse have to be? Okay, so that was one of the special triangles, a 3, 4, 5. Well, we have 2 other special triangles. They are going to be 45, 45, 90s and 30, 60, 90s. So this is called a 45, 45, 90. This one is called a 30, 60, 90. Where am I coming up with those names from? The angles. Okay, good. All right. What kind of a triangle is that first one?
Isosceles.
Isosceles. And I know that because the base angles are the same. Okay, so it's always going to follow a ratio of, I know they used y, but I'm going to use x, okay? X, x, x root 2, okay? Did I show you how, last year, did I show you how they come up with this?
Yes.
Okay,
Yeah, no, it was like
cutting a square in half?
yeah, but I think it was like 2 years ago.
Yeah, it might have been. Okay, so let's look at this one. So 30, 60, 90 follows a ratio, and it goes x, x root 3, and 2x. Okay? All right, so go ahead and hit enter. Let's talk about how we would use these. Go ahead and hit enter. Tell me I gave some. Hit enter. And enter. Go back to the special rights. We'll do special rights on their own. I'll do some examples later. Go ahead and stop the video, please. I will do those separate. Go ahead and do what you